Hello and welcome to the course of Heat Engineering. This is Unit 2, Heat Transfer. In this unit, we will talk about the various mode of heat transfer like conduction, convection and radiation. We will also discuss about the mechanism how this mode heat how these modes of heat transfers take place. So student, you must have undergone the course of thermodynamics in previous semester. So first we will talk about what is the difference between thermodynamics and heat transfer. In thermodynamics you have studied about the basics thermodynamics law, the first law, second law and third law. So on the basis of these laws we can tell about whenever a process takes place, we can calculate how much heat is transferred and how much work is done using the second law of thermodynamics. And we can also tell about the final state of the system, means we can tell about the properties of the system after the completion of the process. We do not calculate how much time it requires for the heat transfer to take place. So the thermodynamics deals with the amount of heat transfer when a system undergoes a process from one equilibrium of state to another, while in heat transfer we are interested in the rate of heat transfer, how much time it will take for the heat transfer to take place and at what rate the heat is transferred, and we also calculate the temperature distribution inside the body from which the heat transfer takes place. So basically both of these branches of mechanical engineering complements each other. Modes of heat transfer. So basically heat is also a form of energy that can be transferred from one system to another. For example, when we turn the burner on of a gas stove, the heat is transferred to the water in the pot and water starts boiling. So basically there are three modes of heat transfer: conduction, convection and radiation. You must have experienced that whenever we heat a solid, for example, at one end, the other end also got heated. So this mode of heat transfer is known as conduction. In this mode of heat transfer, the transfer of energy takes place at the molecular level. The more energetic particles transfer energy to the less energetic particles. The second is convection. For example, if you heat the water at one corner, so after some time the whole of the pot will be at an elevated temperature because the heated water's particles move from one place to another place. The third mode of heat transfer is called radiation. For example, the heat transfer from the sun to the earth take place in this mode of radiation. Conduction. As I have already told you that the conduction is the transfer of energy from more energetic particles to the adjacent less energetic as a result of interaction between the particles. So this mode of heat transfer take place at molecular level. So it can take place in solids, liquids or gases. So in conduction, the energy is transferred across a system boundary due to temperature difference. So if you take a slab of length or L and thickness X, then the energy transferred will be through the conduction from the one side of plate to the another side. So this is because of the temperature difference between the left face of the slab and the right face of the slab. So conduction needs matter and it does not require any bulk motion of matter. Rather, it's as I told you a molecular phenomena. The rate of heat transfer in conduction mode can be given by the Fourier's law, that is, the rate of heat transfer is directly proportional to the temperature gradient across the faces or the boundaries. Mechanism of conduction. Conduction can take place by the diffusion or by the collision of molecules. So suppose there is a lattice, a network of atoms. So the atom on receiving the energy in the form of heat will start vibrating. So these vibrating atoms on the right side will induce vibration to the neighboring structure of atom. So after a while this whole structure will start vibrating and thus the heat is transferred from one side to another side. Another process is by collision. In collision, the particle from hot side this will collide and goes to the cold side, and after collision they transfer their energy to the cold particle and thus both these particles gain some energy. So in this way the energized hot particle transfer their energy to the cold particle and thus this process keeps on going. Second mode of heat transfer is convection. So in convection the energy is transferred across the system boundary due to temperature difference and also by the intermolecular interactions and the bulk transport of hot fluid towards the colder region. Convection needs fluid matter, so convection can only take place in liquid and gases. The quantification of convection can be done by the Newton's law of cooling, where the heat transfer is proportional to the exposed area, in which the H is called heat transfer coefficient and AS is the exposed surface area and del T is the temperature difference. So for example, if there is a plate which is solid and at a temperature Ts and there is a moving fluid coming from left to right which is at the temperature T infinity, and suppose that the temperature of the solid is greater than the temperature of the moving fluid. So the heat transfer will take place from this solid to this moving fluid. So heat will be transferred from the conduction mode from the adjacent layer of the moving fluid by this solid and also by the transport of the bulk motion of the matter which are heated when they come into contact with the elevated temperature of the solid surface. So convection, the heat transfer coefficient is not a property of the material, rather it depends upon the various parameters like the geometry of the surface, flow characteristic, whether the flow is laminar, turbulent, and also the thermodynamic properties of flow. The detail of heat transfer coefficient will be given in the next lectures. So there are basically two type of convection process, free or natural convection and forced convection. Free or natural convection are induced by buoyancy forces. So whenever a fluid is heated, it becomes less denser and rises and give its place to the colder fluid particles. In forced convection, the convection is enhanced by some external means by improving the fluid motion, etc. So by comparing the typical values of heat transfer coefficient, we can know which mode of heat transfer is faster. So in cases of gases, the coefficient of heat transfer for free convection ranges from 2 to 25 and in liquid it is quite high in the range of 50 to 100. And for the case of forced convection, in gases it is 25 to 2 to 50 and in case of liquid it is 50 to 20,000. And in case of boiling or condensation, the rate The heat transfer coefficient is very high and can be up to 1 lakh. Mechanism of natural convection. So, as I have told you that the natural convection takes place because of the buoyancy. Whenever a fluid comes into contact of a hard surface, the fluid gets heated and this fluid becomes less denser and so it rises because of the buoyancy force. So the warm fluid rises and gives the place to the cold fluid, and this circulations keeps on until the temperature becomes uniform. The third mode of heat transfer is radiation. Unlike the conduction and convection, radiation doesn't need any medium like solid or fluid. Rather, in this mode, the heat is transferred by electromagnetic radiation that arises due to the temperature difference between the bodies. So, the radiation is measured in terms of emissivity. Emissivity is a property of the surface and can be given as this formula, and it is proportional to the temperature of the solid body to the power 4. So we can conceive radiation as a wave in which the incident incoming radiation strike with the surface and get reflected. Some part of the radiation is transmitted through the object and some part of this is absorbed by the body. Convection, conduction and radiation can also take place combined. For example, when we heat a pot, the handle of the pot gets heated by the conduction because the rest of the pot is hotter. So it transfer energy to this handle. Also, the fluid inside the pot transfer heat by the bulk motion, and from this heated coal or burner, the heat is also transferred by radiation to this pot and surrounding.